one goes better, I guess. Bloop. All right, same elements, different composition, different properties. Because they have different numbers of atoms, right? So law of definite proportions say if you want to have a certain compound, you have to have them in the right proportions. Law of multiple proportions says you can use the same elements for different things. Again, mass data is what we gather in the laboratory from a sample of material. And then chemical formula is using the chemical formula. So we did a quick one for water right at the end on Tuesday. We'll do some more in here today. And again, you know how to do percent. It's the part out of the total. The thing that gets tricky for these is that they throw in element names and compounds and you don't know what those are and you've never seen them before and it really doesn't matter. So try not to let yourself get too hung up on that, okay? So if you know the mass of each of the elements and you know the total mass, you can calculate the percent. You just divide those numbers and multiply by 100. All right, so this is the explanation. It's not very good, I don't think, from the book. You take the mass of the element that you've obtained from the mass of the total sample. They say of compound. And multiply by 100, easy peasy. Okay, not hard. Thank you. And there's a really fun lab that I like to do with the burners and crucibles and everything, but it's a lab that is like you can barely get it done in 60 minutes. We are not going to be able to get it done in 40 minutes. And if it sits overnight, then moisture from the air gets in and it just doesn't work. So I'm thinking I'm going to do this as a demo video thing like I did first semester with a bunch of stuff and give you the data and we'll work through it. But really weird thing happens when you take this shiny silver metal, and I haven't actually even pulled it out yet all day. In my drawer somewhere. Maybe it's just as well. I didn't try it yesterday. There we go. So magnesium is an alkaline earth metal, and it's shiny and silver, but it tarnishes. It gets this. It's actually a nitride on the outside, the black stuff. And so anyway, you take a piece of metal like this, you heat it up super hot in the crucibles, and it reacts with oxygen. That's a tank of oxygen. It reacts with oxygen in the air, and it makes this white ashy compound that's magnesium oxide. So if everything goes perfectly in the experiment, you should get the percentages that we're going to get today. But I'm jumping the gun. So somebody read the problem for me. Logan, would you read this question?
With a 13.6 gram sample of the compound containing only magnesium and oxygen is decomposed, 5.4 grams of oxygen is obtained. What is the percentage composition of this compound?
Excellent. So magnesium and oxygen, you guys know magnesium's Mg, you know oxygen is O. You should also know that magnesium being in group 2 has 2 valence electrons, which it loses. Oxygen has 6 valence electrons, it wants 2 more. Guess what? +2 -2 likes to make a compound. So the compound's just MgO, magnesium oxide. That's not that important. I'm just kind of like using that as a review. Sample, the total is given to you at 13.60 grams. And they tell you there's 5.40 grams of oxygen. And unfortunately, there's not enough information to solve this problem. If you're going to find the percent composition, you need to know both masses for both of the elements. How are we going to figure that out? Lauren, what do you think? Subtract it from How come? Because we want to find the mass of the magnesium, right? We know the mass of oxygen. We don't know the mass of magnesium. Simple. If this is both of them together, all we have to do is subtract, and hopefully everybody gets 8.20. We good? I know it's 6 periods, but tell me if that doesn't make sense. But that's the missing piece. They forgot to tell us that. What the heck? You're smart enough to figure it out. All right. So we know that we've got 8.20 grams of magnesium. Great. And then all you have to do is take the part that comes from each of the elements and divide it by the total of the compound. So for magnesium's percent, take the 8.20 divided by 13.60 times 100. And the percent of oxygen is going to be the 5.40 divided by 13.60 times 100. And just like normal percentages, push B buttons and you should have it. Turn to your neighbor, see if they got the same thing. Yes.
This is like the part that does it specifically ask for the
It just says percent composition. So you need to know that it's composed of those two elements.
Oh, okay.
So you find the percent of each of those elements. Good question. Yeah, so it's not going to tell you what to do. That's the other, is a percent composition. What part of this comes from each of the elements? And so we're just doing 2 binary elements right now, but you could do bigger ones with more. All right, Julian, what'd you get for the percentage for magnesium?
Nothing yet.
Please do. Do you have a calculator? Okay. $60.29, and the book usually rounds it to the tenths for percent. And I'm okay with that for percents. I would prefer 60.29, honestly, but all my examples on the slides are going to be to the tenths because that's what the book does. Yeah, we'll talk more about that. Everybody get that? Okay, and then Caius, what'd you get for oxygen?
I got 39.70.
Okay. And hopefully everybody got that. And if you do it on your calculator, I think it doesn't come out to be exactly that, but it comes out 39.71 would be actually what I would do it because it's 7059. So that's actually going to be a 1 here. Doesn't make a whole ton of difference for our situation. So we're not going to worry about it that much. Who cares about pennies, right? Nobody picks up pennies anymore. But it does add up eventually sometimes. So, of course, all of you, I hope, were thinking of how to check your answer, right? You could have just taken 60.3 and subtracted it from 100 and gotten this as well. I don't recommend doing that. It's a good way to check your answer, but I would always recommend that you do the calculation and know that they should add up to 100 just on the minuscule chance that you might have pushed a button wrong, okay? So hopefully that makes sense to everybody. Good? All right, ready to try one on your own? I'm going to have somebody else read this one too. Bethany.
When a 14.2 gram sample of mercury 2 oxide is decomposed into its elements by heating 13.2 grams
I know that's the. I think that's why they did that on purpose. Anybody know what Hg is? Hydrogyron. It's mercury. So it's what?
Oh, mercury.
Yeah.
I didn't hear.
Yeah. So mercury 2 is mercury. Roman numeral 2 means it has a +2 charge. Oxygen has a what? -2. So this is going to go together in the same atom proportions, 1:1, like magnesium oxide. Totally different percentages. Okay, so I think that's why the book threw that in there. One, because most people don't remember what mercury is, but also because it's in it at the atomic level, it's in the same proportion, 1:1. Mass wise, it's hugely different. That's how we know mercury has a big atom, right? So we know that the compound has mercury and oxygen, and we know it's 14.2 grams. We know that the mercury is 13.2 of those grams. What's the oxygens? 1. Okay, so this is the total, and each element contributes to that total. So go ahead and work those percents. Talk to your neighbors if you need to. Raise your hand if you need help. Any luck getting in? No, so what? Did anybody else get picked up? Gabby, were you able to get in yet?
Yeah, I got back in.
Okay.
I think this is the one. No, like, because to get back. I did it. Yay! So exciting. The one that you found Remember, this is always No, this is me. This is last essay.
Oh.
Yeah, I got 92.9.
So it's okay to talk about chemistry. Gabby, what you get for mercury?
Oh, I got 92.9. Wait, hold on. For the first one,
Uh-huh.
I got 92.95, but then you rounded up to 93, right?
Yeah, it's 92.9577.
Yeah.
So you could, if you're going to the hundredths place on percents, which is perfectly fine, you could just go 0.96. But if you're going to the tenths place, yes, it would make it 93.
So on like a test, would you want us to
You'll
do
be able to.
92.96?
I'll tell you if I want you to do it that close. Yeah. And then so you should be able to go, well, the oxygen should be what? Gwen?
7.0 or 7.0.
At 7.0 and a little teeny bit, right? So we're fine with 93% and 7% and 7.0% and 93.0%. Got to get those extra digits in there. And they should add up to 100 again. Did everybody get that? Yay! Okay. So once you get past the what the heck is HG, and once you get past word problems, it's really not that bad. All right. So the next piece to this is what I did really fast on Tuesday with water. And that is, you've got a formula find the percent composition from the formula. So for this one, you need to know the mass each element contributes, and then you need to know the molar mass. Well, guess what? Almost all of these problems, you have to find the molar mass on your own. They're not going to give it to you. Okay, so that was a problem from a couple of weeks ago, is finding the molar mass. So this time it says mass of element. And I should say mass of each element separately. And then you divide it by the molar mass of the compound. And this is where you need your periodic table. Okay, it's not an analysis in the laboratory. It's just looking at the formula. And multiply by 100. I always leave that off. Okay. Whew. Time for a nap, huh?
Yeah.
Pastime. All right. We've talked about propane before. You built it when we did our molecular models. Propane is C3H8. What does that mean? That means instead of writing CCC, instead of writing all that, right, we just compact it. But we have to account for all the carbons, and we have to account for all the hydrogens. So the cool thing is when you're doing these problems, the mass values come off of the periodic table. I guess I should really do it like this. And then you've got the part from carbon, you've got the part from hydrogen. All you have to do is figure out the total and do a little division. So this is also tricky. So I'm going to make you do this. Michael, tell me what the mass on the periodic table is to the pennies place, the hundreds, for carbon. Uh-huh. So that is out to that's exactly what it says on the periodic table. We're just going to go, you guys get what I mean by go to the pennies place, the hundreds place. So just round to that spot. We want as many digits as possible, but some of them are like too many. Okay, so you don't need all of them. And then for hydrogen, Jack Conte. Perfect.
If you put 1.02 is
That would be incorrect. So it's 1.0079.
mine says 1.008, so that's what I was going
So the
to
001, yeah. Okay, so 12.01 times 3, 36.03, 8.01, 8 times 1.01 is 8.08. And again, you know, honestly, is a penny going to make a lot of difference in your world? No. Okay. But when you start getting into big molecules that have lots of atoms, you know, it does start to add up. I mean, all of a sudden now, instead of pennies, I got a dime and a penny. And maybe you won't pick up a penny off the ground, but most of you probably pick up a dime, if that makes any sense. I don't know if I'm making any sense. I'm being kind of silly about it, but it does add up eventually. Okay. So, yeah, I want you to do all your mass calculations to the hundredths place, to the pennies. So that's why I make a deal of it. So now we have our part from carbon is 36. The total is your molar mass. So to do the percents, part over the total. Okay, the contribution from carbon divided by the whole compound. The contribution from the hydrogen divided by the mass of the whole compound.
How many times 100 by both of them?
Yes, because they're different percents. And so these are going to come out on here because I haven't done it all the way out on my answers. But again, the book just goes to the tenths. I want you to do more. When you go to college, they're going to do it out to the thousandths place. So And Aiden, did you get any calculating done yet? Am I going too fast?
$81.68.
81.8678 is what I have. So
81.79.
did I push in the wrong buttons?
I got
I put 86 too.
Oh, I missed one. My bad. I put in 44.01.
Oh, so did I.
There it is, 81.6822. Beautiful. Sorry, Aiden. Okay. And you could obviously round that to, if you're not doing it all the way like the book, you could have it at 81.8. Oops, is that right? Did I do something wrong again? Oh, it's because they're not going out to the hundreds. So 36.03 divided by 44.11 should be 81.68. They come up when you don't round, when you don't go out to the hundreds place, they only get, we get a little bit lower. So 81.7, pretty close to 81.8. Yes?
Yes.
Good enough for government work, right? Now, again, you could look at the 100 and subtract that from the 100, but it's always best to do the calculation. And I think it comes out to be, I can't remember anymore. It's too late in the day, sorry. 18.3178, so 18.3. That says 18.2. It just got rounded differently. So don't freak out when you're out to those tenths and hundredths places. If they come off by just one, it's okay. It's not going to be the end of the world, but it should add up to be 100. Yes? All right. All right. Don't, it says to just do nitrogen. Here's what I want you to do. I want you to do on your own, just B. Anybody know what that's called? NH4NO3. We actually did the molar mass of this 2 weeks ago. Anybody? Got half of it right. No trioxide. It's ionic. It's ammonium. Nick the camel. Huh? Guys.
Ammonium nitrate.
Yay! Okay, so both of you. Good job. Ammonium, the +1, nitrate, the -1, polyatomic ions. So I'm just going to ask you, what's the percent composition of ammonium nitrate? What does that mean? That means what part comes from nitrogen, what part comes from hydrogen, what part comes from oxygen. Okay, what's the percentage of nitrogen? What's the percentage of hydrogen? What's the percentage of oxygen? The tricky one with this compound, like what we did a couple weeks ago, there's 2 nitrogens, but they're not together. They still count. Okay, this is a 1 and this is a 1. That makes 2. The subscript on here is 4. That's easy. The subscript here is 3. All right, have at it and see what you get. 14.01. You can times it by 2.
Okay, so do I do?
If you do both of them, it's 14.01 and 14.01. Or it's 14.01 times 2.
Oh, okay.
Yeah. So, I mean, we could do 1.01, 1.01, 1.01, 1.01, 16, you know. It's just easier to do it by 2. But yeah. Oh. Check with your neighbor, see if they got the same thing you did. All 3. It says just nitrogen. I told you I want you to do the whole thing just for B.
Oh, wait,
80.06 is the molar mass.
I get 48.2.
Because you forgot to do something? I don't know. 48 is for oxygen. That's just the part from oxygen.
It was oxygen 3. I wrote just oxygen.
I got my subscription mixed up for Australia, so it happened. Beautiful. Logan's got all the answers. Good job. So 14.01, 1.01, 16.00, and 48 gives you the 80.06 grams per mole. That's your total. 28.02 divided by 80.06. Logan.
34. Rounded up.
Yeah, you got to round it up on this one because it's 34.9988. And then 4.04, what'd you get? Haley.
I'm doing it right now.
Okay. What'd you get? Colin. What'd you get? Jack Burmosel. Okay. That's a little high. Haley, what'd you get?
I put 5.03.
I got 5.0462, which would round to 5.05. But here's the other thing. It's 0462. So here's the deal with rounding. That's less than 500, right? So really this should go off. Okay. But we end up rounding it up, which would end up making that 5.1, but you don't need to do that. So if you have it on there, great. If you don't, it's fine too. 5.05. And Galileo, what you get for oxygen? Okay. Good. 60.00 because it's 59.955 works for me. So if you add those up, it's going to come up a little bit higher, a nickel higher, to use the money analogy because everybody understands about money. It comes up at just a little bit above 100. But if you're talking $100 and you get 5 extra cents, does that really matter to you? Probably not. Okay, it's okay. 100. All right. So hopefully doing percents isn't too awful. Gosh darn it. So thought I was going to give you more time at the end so we can check passwords and stuff. I'm going to wrap this up right now. The book does a little weird thing. So the other way, you can use these in reverse, right? With percents, you can find mass. So we were using mass to find percents, you can go the other direction. If you're scooping up ore and you want to have a certain amount of metal, you know the percent composition of the ore, like bauxite is the ore for aluminum, and it's combined with oxygen. So you know how much aluminum's in that should be in that ore based on the percent composition, and you can figure out if you got enough stuff dug up. When you use percents in calculations, you have to change it to the decimal value. The book does this weirdo thing, 81.8 over 100, which is what percent means, right? Part out of 100. It's really should be in just the decimals. Okay, you don't need to put a fraction. Everybody hates fractions. Don't put fractions in there. Move your decimals over. The only place, right, you're dividing by 100. The only problem kids have with percents is they forget on single digit percents to move it 2 places and put a 0 in there. Okay, so try to remember to do that. All right, I am done blabbering about percents. Does anybody have questions? Anybody at home have questions? Okay, I'm going to go ahead and stop recording and stop sharing, and I'm going to